Today we'll continue in requirement modeling, which is the first phase of commit methods or commit approach. So we already talked about the goal and the scenario, which is the first part of requirement modeling. So today we'll talk about the use case. I don't think the use case is a new topic for you, but as I told you, there is something, a small thing you have to focus on that, which is different than the software or the information system. So in today, we just an introduction, and then we will see what's this use case diagram, and then the use case description, and then we will see use case or a case study for autonomous system, and how we can generate or how we can develop this the how we can develop the use case model. So guys, this is our graph. Every time I will show you this and I will show you where we stop. So as you see here, requirement modeling. We're still in the first step, which is requirement modeling. Okay, we are in requirement modeling. So we already talked about the goal and scenario, and today we'll see how we can develop the use case model. And we have still these two parts, and the third part, which is autonomous system verification. So first we will talk about use case. So the question here, does the use case diagram use for describing the system structure or system behavior? This is a question. I need your help to answer this question. Is it describe? You see the use case, you know the use case. So it's used for describing the structure or describing the behavior.
Certain answer.
Again,
I think maybe system behavior.
behavior. Okay, anyone, all of you, anyone it's have different opinion or all of you agree? If different opinion, just tell. Yes, actually it's the behavior because we will see, I give you one sentence later. It's present or describe the interaction between the system components. So anything describe the interaction, so this is behavior. Structure, actually, if you talk about, for example, the object, the class, the anything is related, something is static and don't change with time. So that's one is structure. So for in UML diagram, we will see today is the use case diagram. We have many here, many diagrams. One of them in the behaviors is the use case diagram. This is maybe also one of the slides that every time we will see where we will use or which one we will use. So here the list of diagrams. Later when you want to compare the diagrams and why we select this, you can go back to these slides. We have here the last one, which is the use case diagram, and the use case diagram used to interact or used to describe the interaction between the system and the user. And here the user, we have different type of user, not only human user. So the use case model, this is our topic. What's the use case model? Here is the use case model. Use case model is how the user interact with the system. As I told you here, the user, actually maybe we can use more general words instead of user. We can use what? Maybe actors, or we can, because if you say only users, maybe it's come to your minds it's the human, but in fact we mean anything interact with the system, anything, not only human, not only human. And this is maybe the main difference between this subject and the others. We're not talking about human only. Human is one of. So when you uh, find the actors, you should also keep in your mind which other actors than the human. So in use case diagram, actually, we describe the functions. We describe the function, and this is the easy way. Maybe you find a lot of tips to help you how you can describe or how you can develop the use case. But my way is to first to find the requirements. No, yes, to find the function requirements. What the function requirements, and then all these function requirement, maybe not all, most of these function requirement is can be translated or can be developed as a use case. So for example, okay, registration can be one use case. Sign in, sign up, find person. Okay, this is all can be also its use case. So here we use it. We use the use case diagram to describe the function requirements. Okay, and this actually, if you remember last time, we start with the scenario because we need it. We need the scenario, and these techniques or this use case diagram, it's scenario based. Scenario based. In fact, actually, it shows us one scenario, at least one scenario, or in the description we have the main scenario and the alternative scenario. So it's scenario based. So based on your scenario, that's why we have to describe or list all the scenario first, and then based on that we can develop the use case diagram and description. So it's done in UML. Okay, here we have to identify the actors, describe the interaction itself. Okay, set of use cases should be described. So this is also what you have to know to do. It's to describe a set of use cases. Even you can okay develop only one use cases as a package, but in the end you have to describe all of them. Or as I show you, you can describe it is one by one. Okay, the last point here, we say, okay, it's extract from the scenario. So once you have the scenario, it's easy for you to develop these use cases. The use cases also serve for capturing the function. The function, okay, even for when you're developing the use case, maybe later you can back and refine the function requirement. For example, not only function requirement and other type of, for example, the scenario, the others. I mean, when you develop the use cases, maybe you can find some errors, some mistake, and then you come back to describe the function from the beginning. So here, uh, as a use case, we can see is use case it's uh, deal with the system or as actors. We have the actors and then we have the system. This is the main components of this use case. So here the actors, it can be anything. Later I will show you the list of components of the use case. But we have the system and we have the actors. And the system here like is black box. Black box. You don't know what's inside. Maybe I mean there is no details. There is some abstraction there, no details to describe what the function of this use case. So its use case, it's we can say it's a block box. Also, using this, we can also identify the boundaries. The boundaries actually it's when you have the system and you have the user. Here, or we can say it's the user actually. When I say the user, don't say that's mean the human. Okay, the user does mean any input, any input. Even it's human, if device, input, output, environment. So this is all we can say is user. So there is a boundary between the user and this system. So if you see later we will see how we can also represent this boundary in our system. We have also, we can represent it as what? as object. So we say it's boundary object or boundary class. So we have here this point. Okay, these use cases actually it's important because based on this use case, you will develop your dynamic model as well. You will develop also the design model. So in the same things, also this use case can be refined in the dynamic model because it will be used. It will be used, so can be refined in this because there here maybe we'll just describe the actors and the system. So later when you design, for example, the dynamic model, you want to describe the object. So you can see now each actors should be is object as well. Each we have interface between the system, and so you can refine them later, or even you can use it also in a dynamic model and design model. Also, the last point, guys, here we talk about the use case, test case. The test case also we can develop the test case, or I mean we can start thinking about the testing and what the test case that we needed, or at least what the acceptance testing that we can develop. So here the main components of the use case diagram, we have the use case itself, which is the function that belong to this system. The second thing is the actors. The actors, actually, it's any entities. You see here is good definition. It's any entities that interact with the system. So it can be human, can be devices, can be even sometimes it's a system, also can be actors. I mean another system or external system. So the relationship between these use cases and the boundary. So here in quick we will see this one because you know already this notation. So the first one is the use cases itself. Just the circle and then you do or you write this use case, the name of the use cases. So the second one is the actors. As you see here, all the actors it's look like human, like a human. So but in fact you can use any as we write here, role not a person. It's like a person. I mean this is this icon like a person, but in fact it's involve other actors or other entities. So here I think I write here yesterday's slide. I give another slide only about the actors. The actors here, guys, as I told you many times, we don't have only human actors. We have many different type of actors. So the first one is the human. The first one is the human, and this human, any human that is interact with the system. So the second one is the external input-output device. So this is important for us. Any other devices it's interact with the system also can be considered as actors. Okay. Example here, guys, if you have a sensors, if you have, for example, display screen, if you have, we can see is also is a keypad or the keyboard. This is actually some of them they don't consider it as an input-output device, but it's still also actors. So the third one is timer. What's the timer here and how the timer can be actors? Actually, the timer here, guys, sometime, okay, for example, as the example that you will see today, we have an example, and this example, to, for example, view the daily report, for example, or weekly reports. So the system is working by itself, okay, and then just need someone or something, not someone, something, to just give him we can say is tick. Okay, this time for view report, this time for send report. So here we need a timer. So if you see is interact, this timer give instruction or interact with the system, so it's actor. Okay, I think it's clear this point. Actors or a timer, also it's interact or it's input device, or input is can be input device, maybe even can be also is a method, but is a timer. Timer is give the instruction for the system, so give some input to the system, so it's considered as actors. The third one or the fourth one is the external system. If there is many systems, okay, your system has interact with another system, for example ATM machine interact with the main system which is in the bank system, so this is also interact with the system, so it's considered as actors, primary actors. And okay, this is actually, we can say, the type of the actors. The type of the actors, we have some is primary and some it's uh, secondary. So the primary is the one is initiate the use cases, and the actors, the one is we can say is response or react to these use cases. For example, if we say we have the user start, for example, want to check his balance in the bank, he key in the PIN number, after that request for example to see the balance. So here we have another actors will respond to this, for example at least is the ATM machine itself or even the bank. So this one, so the user it's the primary and the bank it's the secondary actors. So many use case devices or external system, this is not related to this, we can maybe it's until the external device, this is the type of actors. So this is just some information, even not complete. So this one is not only the physical, not physical at this point, say the input and the output, not only physical system, not only, maybe can also some software, something like timer is not physical. So as I mentioned also, is not only human, it's considered as the actors, also non-human also as the sensors, it's actors. So this is, I think it's all about the actors. No, still we have the same. It's the same, guys, same one. We have, as I say here, we have the human, we can see the user. We have the application as external system. We have the devices also. We have some this is another category or another classification of the actors. User as a human, for example, here they give example of the administrator, manager, customer. Application, which is external systems. Devices as a sensors, as actors, or as actuators. And the last one is the events, if we have clock or timer. So this is another classification for the actors. So here the system boundary is to show this, okay, this is the system and this is others, is the other is will be the actors. And here later this one, even you saw this box, but later we have to represent this boundary between the system and actors as object. So the type of the relation, we have here, this one I think it's also it's all topics, what the different types that we have between the actors and the systems. We have the association, we have the extend, include, and generalization. Actually, we use this is the main one, the association. And I think any normal, if we have the system, if we have a system, and then the normal relation between the system and actors, or between the use case and the actors, it's the association, it's the normal link. So we have sometime, okay, extend and include. So what the difference? I have one slide only about that. So sometimes we have some use cases, it's, you can say it's must be done. If you done, if this is you can say implemented, or this use case is run, so there is another cases, it's another use case must be follow this use case, and some of them it's not necessary. You can see this example here, this examples. For example, sneezing. If you sneeze, you have to close your eyes. It's, you must. But sometimes if someone beside you, maybe you say, okay, excuse me. So this is the main difference between include and extend. Okay, include, it's must be done or must be follow the main use cases, while extend it's sometime but not necessary. So here an example, of these use cases. Okay, the last, okay, this me, and the generalization, actually sometimes there is one actors, for example, it's there maybe we say, can say these actors, and we have another, for example, two actors, and these two actors is doing the same behavior. So, and then they react same. So later we can say, okay, both of them, it can be represented as one. Okay, and then the system is only interact with the main one. Okay, this is, so this is, we can say, that's why I put this symbol. That's one, I mean, the system only interact with the main one, while the others is just a generalization from these actors. Here an example, if you see here, is a call. This is system for calling. So what we can see, what the main function of calling or for your phone. For example, okay, handling messaging, handling calls, manning the bells. For example, you have, this is the main function of your system. So each function represent as one use cases, and then see what the interact, or how these actors, or how the actors it's interact with this system, with the system. Here also I show guys the actors, the association, the boundary system, and the use cases. This is the purpose of this example. What else we have here, guys? This is also more explanation, you can read it. Okay, this is the extent, also the association. So guys, we come to this topic, which is use case description. Okay, there we describe the use case. In the use case diagram, we describe the use case, but in graphical base. So here we just describe it. It maybe it's more details, just textual base. Here we write. Also here we write the sequence of the system, or the scenario of these use cases, and alternative of this sequence. So here the form, or the template of the system, or the use cases, So here the name, the summary of. I think you are familiar with this. You know, I know that you already do this one. So here the template, and just describe the use case diagram, but in text. Okay. So guys, today